Hi. Oh, this is funny again. We are using another black wing pencil, and this is black wing to the 100. I've used that for a while, so it's like there's a bit history there. Yeah. So, and my 2 eraser. This question requires sketching, so I have my ruler here with me. So make sure you got all the material, and let's get started. Okay. So this time it's like cooling soup. Cooling, like physics people might know that when things get cool down, it's an exponential decay. Application of exponential as well. So this time it's the decay. So temperature S degree with the pot and stovetop, blah blah blah. So I don't care about the situation. Actually, I do have to care about it, but this is the function here. And time is in minutes, so be careful with those. Initial, this is a very important word. Initial, you're going to learn that. Even me, second language people, t have to be equal to 0 for initial. Pretty important, we need to know that. We need to show it's 90, so we have to show more steps from that. So we have A, which is S0 equals to 20 plus 70 times 2 times 7 to negative 0.4 times 0. So that gives us 20 plus 70. You need to show that you know that 2 power 0 is 0. And 2 power 0 is 1, not 0. 1. Slip my tongue. So now we have, this is show that. So you do not get any points for just writing down in that's 190 because they gave you the answer already. You have to do the working. So show a bit more working for them. And sketch the function of it. So we have to use our GDC with those, so delete old ones, and we have 20 plus 70 times 2.72 power negative 0.4 x. That should work. Hey, again we lost our function here, so we need to go back to the V window to check it out. And it's pretty high temperature there. Initial is 90, so our domain range should be go to at least, I will assume that 120, like water boil. Like this is the time when you get to the context. Water or soup shouldn't be more than 120 degrees, right? So 100 should be 100. So 120 degrees should be the best for us. And for the soup cool down, it might start from should be start from 0, but I give it a 2 there. And I don't know how long it's going to be cool down, so I give it about, oh no, they give me the domain already, so a bit more from there. So it's negative 2 to 12 because this is the domain. Okay, pretty lovely now. So when we draw that, we have to draw our x-axis and y-axis. I use my ruler here. Use your ruler wisely. And then when you sketch, make sure you have all your intercept ready. So this is 90 and it should go down that way. Stop right there. Make it a 10. Alright, and then you might need to find the asymptote as well, because when it's never get lower than 10, so 20. So we have to write down the asymptotes, because just in case that you know that. So it's never touch anything below 20. That's weird. Oh yeah, that makes sense because its room temperature should be around 20. Depends on where you are. So for this case, it's 20 here. Alright, W degree is the pot for after 2 minutes. So what you need to do, after the soup, remove the small open. A pot of water, that's just this time water, after the soup is heated, is removed and so find the intersecting point with it. So I will have to sketch in the other function here. My underline is a bit annoying. So here we go. We have 20x minus 40. Alright, and then we have the we have the domain there. So remember our trick from the last video if you're not. So here we go. Give it a comma and give it the domain there because I got one function there already. So shift the square bracket 2 to 6. Perfect. So we have 2 to 6 there. So I will know that find the intersecting point of it. So C1, G's of intersect. We are using the calculator here, so we need to find the intersecting point. So make sure you write down the both point. So 0.77 rounding and 35.6 going up to 25.5. This is the intersecting points. Alright, it says to be intersecting point, so I will give it a coordinate just in case. Alright, 2, state the meaning of it at the context of the intersecting point. So which means that is equal, so the intersecting point, therefore the temperature, there's no therefore, I'm explaining it. The temperature is the same, which is around 35.5 degree at the time after, not at the time, I didn't have a time there. Language. Around 3.77 minutes. Alright, so this tells us that at this time the temperature is the same, which is 35 degrees. So this is some writing there. Alright, find a range possible that ST is smaller than W. So we want the red on the graph, the blue below red. So this is another trap there. You might say that, because it's the intersecting point, shall it be the range of it, the range possible when ST, the blue, is below that. So it should be anything from 3.77 onwards. You might want to say that. However, there is a domain right there, so we have to put it in. So after that, the temperature is not there, we do not know. So be very careful with it. If you just write down anything x bigger than 3.77, it doesn't work. You have to include this domain here. So that's why long question is could be straightforward, but then it's a bit tricky. So sketch the graph on the same set of part B. So I redraw it here. Indicate clearly the intersecting point. So I will have copy my graph here. Alright, this is 2, this is around 6, and this is the intersecting point. Where's the other number? 5.5. Alright, so I got, let's see. Indicate clearly the intersecting point and the intercept. Yes, that's all I do. I do not have y-intercept for that one. So that is our another 12 point. I can see. Actually, this question is 12 points, and we use a bit longer than 8 minutes, so with a lot of chit chat around. So that's it for our long question on another application of exponential decay for temperature. Alright, until next video, we'll see you next time. Give it a happy face. See you later with the no hair girl. Bye bye.